Four options associated this problem is given to us, and we have to find onto homomorphism from Z to Z, and which are onto. First, understand what is the meaning of onto homomorphism. So first is homomorphism. Homomorphism means these two are either domain or codomain. These are group, and they are forming group with respect to a binary operation, and commonly they are same binary operation. So group homomorphism preserve operation means if two elements A and B, after applying binary operation on AB, then its image also satisfy this property. Means f of A operation B equal to FA operation FB. If this property satisfy, we say homomorphism exists, and we are seeking onto homomorphism means elements from one side satisfying some property, then its image or pre-image will also satisfy same property. For onto, as we know that 1 and -1, these two elements are generator of Z, then its image means f minus 1 or f1 must be the generator of the codomain. For this, we are seeking pre-image of f minus 1 and f1 means 1 and -1. These are generator of Z. So there is only two homomorphism. So option C is correct. The remainder of 37 raised to the power 49 when divided by 7 is. So find the remainder here, and congruence will help us to find the remainder. So what is congruence? If I write A mod n, it means that when I divide A by n, means n divides A, then remainder left is the value of A mod n. So you can write A mod n is R, or sometimes we write B. It means that if this value is subtracted from A, means A minus R is completely or evenly divisible or divided by n. Here remainder may left, or it may be 0 or less than n, but in this case remainder is always 0. So we will apply congruence modulo here when 37 raised to the power 49 is divided by 7 or mod 7. So what is the remainder? Means value of B or sometimes R. We need to find this value. What is R? If A belongs to integer, then A raised to the power P is congruent to A mod P. This is well-known theorem, Fermat theorem. Fermat theorem. So consider P is 7 and value of A is 37. Also the condition which is must applicable here should be GCD of A and P must be 1. So their GCD is 1. GCD of 7 and 37 is 1. So we can apply Fermat theorem here. So 37 raised to the power 49, sorry, 7 is congruent to 37 mod 7. Divide this one. What is the remainder? 7, 5 is 35. So 2 mod 7. Because we are seeking 37 raised to the power 49. And this one we will get when 37 raised to the power 7 is whole raised to the power 7. Means a raised to the power k mod n is same as b raised to the power k mod n. So so raised power 7 both side, 37 raised to the power 7 and whole the power 7 will congruent to 2 raised to the power 7 mod 7. This is 37 or 37 raised to the power 49. I can write mod here, or there is no need. If you can write, you can write or not, is equal to 2 raised to the power 7 mod 7. Now 2 raised to the power 7, 2 raised to the power 5 is 32, multiply by 4, 4 2 is 8 and 4 3 is 12, 128. Means this is same as 128 mod 7. Means divide 128 by 7 and what is the remainder left? 7 1 is 7, 5, 58. 7 8 is 56. So 2 mod 7 means 2 is remainder. Now which one option is giving the value 2? Option C is here. Total number of transposition in the permutation, these are, we have to find total number of transposition. To find total number of transposition, write permutation in cyclic order. As 1 is going to 10, 10 is going to 4, 4 is going to 5, 5 is going to 1, so it is closed here. We write permutation without any symbol or character. So 1, 10, 4, 5. This is our first cycle. Now second is, we have used 1, 10, 4, 5 symbol. Now 2 is going to 9, 9 is going to 7, 7 is going to 8, 8 is going to 2. So it is closed here. So second cycle is 2, 9, 7, 8. This is second cycle. Now which character we have not used? 1, 2, 3. 3 is going to 3. 4, 5. 6 is going to 6. 7, 8, 9, 10. All characters we have used or symbol. So total number of transposition means 1 is going to 10. This is first. 1 is going to 4. 1 is going to 5. 3 transposition from first cycle and again 3 transposition from second cycle. So there are total 6 transpositions for this particular permutation. So option D is correct. Of order 66, the number of silo 11 subgroup is, we can find using silo theorem, and this theorem is related to silo P subgroup. The number of silo P subgroup can be find out using this formula. NP equal to, NP is notation for P silo subgroup, and this number is equal to 1 plus Kp, and this 1 plus Kp divides order of the group. So we have to find number of 11 silo subgroups. So we have to find n11, and this value equal to 1 plus 11k, where 1 plus 11k divides 11k divides order of the group. Order of the group is 66 and 66 can be written as 2 into 3 into 11. So value of k maybe exist as 0, 1, 2, and so on. Particularly for this, 1 plus 11k must divide order of g means 66. So value of k is only 0. No other k will work for this one. If you put k equal to 1, then 1 plus 11 into 1 doesn't divide 66 because of this number is 12 and 12 is doesn't divide 66. And you can choose any other value like 2, 3, 4. All other value of k will not work here. So number of 11 silo subgroup is single, only one. So option A is correct. The total number of surjective group homomorphism from the group Z20 to Z8. We know that number of group homomorphism, if F is a group homomorphism from Z20 to Z8, then we are seeking number we normally denote by hash symbol. This is number of surjective group homomorphism. We are seeking this one. If F is a group homomorphism from Zm to Zn, then number of 1 group homomorphism can be found by Euler-Toten function phi m if m divides n, and number of onto group homomorphism can be found by phi n if n divides m. There is no 1 group homomorphism if m doesn't divide n. Also, there is no onto group homomorphism if n doesn't divide m. This is the basic concept. So we are seeking surjective group homomorphism. It means that should be 1 and onto. It means that there is no onto group homomorphism because of 8 doesn't divide 20. So there is no onto group homomorphism. It means no surjective group homomorphism. So answer is mathematically option B.